Good evening, all. I welcome you all on the behalf of StudyIQ IAS English. My name is Pritesh Maturkar. I extend my warmest regards to everyone, those who are joining me on this fantastic journey, on this very astonishing endeavor, wherein you and me will go on a world tour, where you and me will explore the physiography of Earth using the most potent tool, that is maps. And I, as your able friend, philosopher, and guide, will give you a free of cost world tour wherein you appreciate the basic concepts of a discipline called as geography. So the lectures which I'm presenting you all in this curriculum entitled Geography Through Maps, through this I tend to achieve roughly 50 to 60% coverage of your GS geography discourse, and using this discourse I want that each and every one of you should understand advanced level concepts too. So this discipline or this discourse will also help you in getting the advanced level concepts. So 50 to 60% of your GS mains preparation will be borne by me only in this curriculum. So please treat this curriculum as the basis of your mains preparation as well as your prelims preparation. And the content which I'm showcasing you on the board, the content which I'm explaining you through these lectures, is equally important from utilitarian perspective. So you can apply this content directly in your prelims as well as your mains. And using this, I tend to achieve two things. Number first, your conceptual clarity of atlas marking, your conceptual clarity of locational analysis, and number two, that is again very important, we will also tend to cover current affairs as much as possible through this curriculum, so that you get a hang as to how you can correlate current affairs with the static part of the geography discourse. And please remember guys, geography is a discipline which is heavily focused on locational analysis and interlinkage. So if you want to master the discipline, if you want to excel in the discipline called as geography, so please keep in your back of your mind that you need to be comfortable with two things. Number first, locational analysis, and number two, interlinkage. So slowly we have started the locational analysis and also the interlinkage. So today being the 17th lecture, we have up till now taken 16 lectures. In this 16 lectures, the typical workflow is like this, that in first 5 to 10 minutes, I tend to discuss whatever I did in the previous lecture, and then I explain new concepts. If those new concepts do have practical applicability with regards to atlas, then we open up the world map and we showcase to you. But if it is not there, that if I am finding this information as vital as your basis for understanding maps, then I heavily rely on the data. So yesterday the same thing we did, that I introduced you to the silicate minerals family. I introduced you to some of the important silicate minerals which you have to remember. Okay, so in geomorphology per se, locational analysis will not be that evident because you need some raw data first to understand how the earth functions, how the lithosphere of the earth actually drifts and moves apart. So please keep this in mind, that some sessions for now on, for this week or for next week, will have a little bit of data cramped into them, and this data you can directly apply in your prelims and your mains preparation. But this data is very vital for your understanding of the atlas. And using this curriculum, I tend to cover roughly 15 to 20 marks in your prelims and approximately 100 to 300 marks in your mains. And if essay comes in our purview, if GS paper 3 comes in our purview, then this can easily go up to 400 to 500 marks too. So a big smile on everybody's face that this single curriculum will help you in scoring approximately 200 to 500 marks in your mains. Okay, so let's begin. So as promised by me to all those of you who are watching me live, so each lecture is starting with a beautiful image of a location or of a phenomenon which I've discussed in the last class. So the image which you are seeing on the screen, the image which you are seeing on this interactive flat panel, is the first of the nebula being discovered. This is called as the Helix Nebula, and it is in the constellation of Aquarius. It was the first nebula to be ever discovered. Okay, and if you see this nebula is nothing but a hot dense cloud of gases. So in the middle, this blue color which you are seeing, this is basically of oxygen. Ultraviolet light is coming out, and in ultraviolet light the oxygen comes down as blue, and the outside, the red color which you are seeing, these are the lightest of the gases like hydrogen and helium. This helix nebula has been formed basically because a star exploded over here. So from this star explosion, you have the cosmic dust being thrown out. Okay, so this was the first nebula to be captured in the 1840s. It is named as the helix nebula, and from this cosmic dust, not this cosmic dust per se, but the cosmic dust of the earlier explosions, 6 billion years ago, 7 billion years ago, that cosmic dust has basically come down on Earth, and that cosmic dust has basically translated into the atoms of your body. Okay, so the individual cells in your body, the individual molecules in your body, the individual atoms in your body are existing. Why? Because somewhere down the line this happened in the universe, that cosmic dust came. Due to that, you have the formation of the human body on Earth and basically the life forms on Earth. So again, you owe your origin to the universe. You owe your origin to the cosmos. So such kind of images, such kind of analogy will help you generate deep interest of the understanding of the universe, of the understanding of our Earth, and you will be better able to appreciate the beauty of our planet. And guys, that is my ultimate endeavor with you. You need to understand how Earth manifests at different places. So I gave you a very good analogy. So if we are considering Earth per se, so Earth will use different makeups. Earth will use different filters. Somewhere the filter will be of deserts, somewhere the filter will be of rainforest, somewhere the filter will be of permafrost region, somewhere the filter will be of scattered topography in terms of vast grasslands, or sometimes you will have a water-based topography where you have vast oceans on Earth. So the hydrosphere. So Earth will manifest differently using different filters, using different makeup. So I hope that such kind of things do generate your curiosity. Such things do help you understand your position in the universe. So wherever you feel lonely, whenever you feel that things are not going the way the things should have gone, or you are feeling depressed in this preparation, it might happen, guys, the preparation is so damn intense that you tend to get depressed, that you tend to get lost. So whenever you are feeling lonely, whenever you are feeling depressed, what you should all do, you should just sit and look at the sky above in the night time and just think that for you to exist, for an individual member like you to exist, somewhere in the distant galaxy a star exploded, somewhere in the distant galaxy a black hole merged with another black hole, spilling out immense material of cosmic dust. And because of that, you are existing today. So basically, the universe has worked for your existence. So you are not lonely, guys. You carry the legacy of millions and millions of stars in your body. The universe has exerted for your existence. This is a big line, that universe has basically exerted for your existence on this planet. So you are not at all lonely. You carry 1,000 stars in your body, and you are of course the most shining star on this planet Earth. Why? Because you are preparing for civil services examination, the toughest examination in Asia Pacific. Mind you, second toughest. The first is of Gaokao of China, but for administrative services this can be considered the toughest. Okay, so welcome aboard everyone. So let's begin our discussion from where we left yesterday. So just let me quickly revise what I did yesterday. So yesterday I did introduce you to the silicate mineral family. Yesterday we did venture out into the interiors of Earth per se. And when we started discussing the interiors of the Earth, I did paint you picture of Earth as a whole and Earth as its crust only. Why we need to consider Earth as its crust primarily? Because your interaction with the planet is limited to the land surface. Okay, you are not interacting with the uppermost parts of the atmosphere, neither you are interacting with the core. So your and my interaction on this beautiful planet is limited to the surface of Earth. Hence we need to have a more focus with regards to the Earth's crust. So if I consider Earth as its crust, so if I'm considering only the Earth's crust, then the highest percentage you find is that of elemental oxygen and you have of silica. So inside the Earth's crust, the dominant elements will be elemental O2 and silica. So because of this, the study of silicate minerals become very, very important. And the most dominant silicate minerals, I gave you the list yesterday. So you have quartz, okay, quartz, it is also called as quartzite, okay. Then you have feldspar. Okay, you have feldspar. After feldspar, you do have a mineral called as mica or muscovite. Then you have a mineral called as olivine and pyroxene. So you have olivine and you have pyroxene. Okay, you have olivine and you have got pyroxene. Okay, so olivine and pyroxene you will find in the deep mantle. You will find in the deep mantle. Okay, you will find in the deep mantle, or you will find them between the boundary of mantle and crust. Okay, and I told you that olivine and pyroxene, not pyroxene but predominantly olivine will do what? Olivine will lose rigidity. It will lose rigidity. Okay, it will lose rigidity under sustained stress. Under sustained stress. Under sustained stress, as you go down the earth, the temperature and pressure increases, the stress increases, so it will lose rigidity under sustained stress, and because of this it tend to exist in a semi molten form. Okay, in a semi molten form. Okay, so this is where we ended our discussion yesterday, that with depth, as you go with depth, the silicate minerals, they become more reactive, they become more dark color, they tend to lose their rigidity, and with increasing depth their density also increases. The simple answer to this is why this happens, because as you move down, the temperature and pressure will increase. Okay, so this is where we left yesterday. So today I'm introducing you to the rocks of earth. I'm introducing you to the detailed analysis of the igneous rocks per se. So 3-4 examples of igneous rocks, and then we will move towards the discussion of little bit of crust of earth and how the crust is layered in terms of mechanical rigidity, because that is very important for your understanding of plate movements on earth. So we will primarily focus on that aspects. Those of you who are watching me live, please feel free to comment whether you are getting these aspects, whether you are all appreciating the way I am moving ahead with you. And mind you, I'm only covering those aspects which are necessary for map analysis, guys. Okay, I'm not going into the details of the entire chapter called as geomorphology, entire chapter called as climatology. So I'm just quickly brushing up those things which I feel are important for your understanding of the maps. So this is roughly 30 to 40% of the entire geomorphology coverage itself. Okay, rest is not that difficult. If you get this, rest you all can easily manage. So the only thing which I'm asking you from each and every one of you is to trust me, is to have faith in me. There is a word called as hope. Okay, I normally don't use the word hope. Why? Because hope is like kind of begging. I hope that someday this will happen. No, why you have to beg that someday that will happen? Put blind faith, put blind belief, work hard, do the proper analysis, do meet the proper requirements, and you will definitely achieve something. So keep faith. Faith in what? In me. Faith in what? In the content, and ultimately faith in yourself. Like the way I'm keeping my faith in you, you will also keep faith in me, and you and me will move ahead shoulder to shoulder. Okay. So let's begin with the discussion of the some of the important rocks on earth. So we did the silicate minerals. After silicate minerals, we are now beginning with the discussion of some of the important rocks of earth. So the rocks are basically classified on the basis of their genesis. Genesis means their origin. So on the basis of genesis, genesis it is called as origin. Okay, on the basis of genesis or origin. Okay, the rocks are classified into three groups. Okay, so the first kind of group that you have, it is called as igneous rocks. It is called as igneous rocks. The second group that you have, they are called as sedimentary rocks. Okay, let me write in capital so that you all get it properly. Okay, the first kind of rock, it is called as igneous rock. The second type of rock, it is called as sedimentary rock. Sedimentary rock. Okay, and the third rock that you have, it is called as metamorphic rock. Okay, metamorphic rock. Now what do you need to remember from civil services perspective, that what are the different properties of these rocks and what they basically translate into. Okay, so igneous rocks, they are formed by the cooling and solidification of either magma or lava. Okay, so if you have a igneous rock forming in the inside of the earth's surface, it is formed by the cooling and solidification of magma. And if the volcanic eruption is coming out of the surface and then it is cooling, and then if it is condensing, it will result into formation of extrusive igneous rocks. So you have two igneous rocks, you have intrusive igneous rocks and you have extrusive igneous rocks. When will intrusive igneous rock form? Intrusive igneous rocks will form when magma cools off and densifies, whereas when you will form the extrusive igneous rocks when the lava comes out, when the volcanic eruption comes out. If the volcano is inside the earth, if you have the volcanic eruptions happening inside, it is referred to as magma, whereas if the volcanic material comes out, it is referred to as lava. So if you have lava which is coming out and then if it is cooling and consolidifying, then you will have extrusive igneous rocks being formed. And as igneous rocks are formed by the cooling and consolidification of magma or lava, they are unfossiliferous, they are unstratified, they will not have any layers, they will always be crystalline, you will have finite crystal faces, and most importantly they will be devoid of any life forms. So you need to remember these 3-4 things with regards to the formation of igneous rocks. So how are igneous rocks formed? Okay, so igneous rocks are formed by the cooling and consolidification, by the cooling and consolidification of either magma. So if it is magma, it will be inside the surface of earth, and this will result into formation of intrusive igneous rocks. Whereas if the cooling and consolidification is happening outside the earth's interior, so it will be called as cooling and consolidification of lava. It will be outside the surface of earth, it will be on the surface of earth. This will result into formation of extrusive igneous rocks. And mind you, the igneous rocks, okay, the rocks which are forming by the cooling and consolidification of magma, they will always be crystalline. Crystalline means they will definitely have faces. Okay, they will always be crystalline. They will have some faces. Okay, they will not have any layers. They will not have any layers. Okay, and they will be devoid of organic matter. So these are some of the properties of the igneous rocks. They will always be crystalline, they will always have some faces, and they will not have any layers. As they don't have any layers, so the life forms cannot get trapped inside them. So because of this, what will happen? Because of this, you won't have the formation of fossils. So they will always be unfossiliferous. You will not find fossils. So if you have seen the movie called as Jurassic Park, okay, so there you must have seen that they are extracting the DNA of dinosaur from a mosquito, and that mosquito is basically preserved in the layers of sedimentary rocks. So why? Because you have different layers. As these different layers fuse together and as water and oxygen are removed, the life forms get preserved. But in igneous rocks, do you have any layers? No, it is basically a big chunk of magma or lava which is cooling. So it will result into a brick crystalline structure which will be unfossiliferous, and it will not also have any layers. So these are some of the important properties of the igneous rocks. Now, if I ask you some of the examples of the igneous rocks, okay, so if I'm asking you some of the examples of igneous rocks, the most dominant one, the intrusive and the extrusive. So in intrusive igneous rocks, the first example which you all can remember or which you all know, okay, in your kitchen you have a countertop on which you are preparing the food, on which you are using utensils, and sometimes your mother will bang your head on that. Why? Because you are bothering her so much. Okay. So jokes apart, but that happens normally when you get very agitated or you make your mom very angry, she will bang your head on the granitic top floor of your kitchen. So the most common example of intrusive igneous rocks where you have consolidification and cooling off of magma, it results into formation of what? It results into formation of granite. It results into formation of granite. So you need to remember this. It will result into formation of granite. And another example you can remember of granite is of the intrusive igneous rock. It is called as diorite. So granite and diorite, these two are the dominant rocks of the Earth's interior. Please remember this, guys. Granite and diorite, these are the two most dominant rocks of the Earth's interior. So now, if you move out from your study room, okay, you are sitting in your study room, or some of you might be studying in the kitchen also. Now you are munching watching this lecture, because this being an online medium, I can't see you. Okay. So those of you who are munching on your kitchen countertop, please understand the countertop on which you are sitting, the countertop on which your mom will bang your head if you agitate her, it is granite. Okay. And granite is a intrusive igneous rock. How it is forming, guys? It is forming by the consolidification and cooling off of magma. Whereas another example of intrusive igneous rock is diorite. So granite and diorite, they together make up the bulk of the Earth's interior. Okay, interior in the sense in terms of rocks. Okay, so this is an example of intrusive igneous rocks. Okay, the most common example of extrusive igneous rock, or extrusive means that the volcanic material or the volcanic lava has come out and it is cooling and solidifying on the surface. So the most common example of extrusive igneous rocks you can remember is andesite, and you have basalt. You have andesite and you have basalt. Okay, you must be remembering the name Andes. We discussed the Andean mountains of South America. So the name Andes, it basically comes from andesite. So there you have andesitic eruptions. There you have very violent andesitic eruptions. Hence the name Andes from the word andesite. Okay. So guys, this is the beauty of this discipline, that you can actually appreciate the way I'm teaching, and you can actually appreciate what you manifest on the earth. Okay. So extrusive igneous rocks, andesite and basalt. So andesite is the common rock of continental exterior, whereas basalt is the common rock of the ocean floor. So if I'm summarizing for you all the igneous rocks, the types of igneous rocks you have. So in igneous rocks, you have two kinds of rocks. Number first, you have intrusive rocks. You have intrusive. In intrusive, the most common example is granite and diorite. Granite and diorite. So these are the two most potent intrusive igneous rocks. Whereas if I'm considering extrusive igneous rocks, then you have andesite, and you have basalt. And please remember this, guys, that andesite is the common rock of continental exterior. It is the common rock of continental exterior. Okay. So if you are going somewhere in the fold mountains, so if you are going in the trans-alpine mountain system, if you are going to Rockies, if you are going to Andes, and if you are picking up a rock over there, and if somebody is asking you, please tell me which rock is this, your answer should be andesite. Whereas basalt is the common rock of the ocean floors. Is the common rock of the ocean floors. So, example wise, you only need to remember these rocks. Example wise, you only need to remember the extrusive and the intrusive igneous rocks. This only. So, granite, diorite, andesite, and basalt. Okay. So, these rocks are very important from your civil services prelims and mains perspective. Please keep appreciating these. Okay. Now, apart from this, the other two types of rocks that you have sedimentary rocks. Okay. So, how are sedimentary rocks formed? Okay. Sedimentary rocks will be formed primarily by compaction. Okay. By compaction, by consolidation, and a method which is called as lithification. A method called as lithification. Okay, please remember this word, lithification. What do you mean by lithification, guys? Okay, so lithification is basically different layers of rocks coming together, and in that you have removal of water and oxygen. So basically different layers will fuse together. Okay, different layers will accumulate, different layers will come together to result into the lithification or the compaction or the consolidation of the materials. Okay, so lithification is basically different components, okay, different components fusing to form a single rock, fusing to form a single rock, and sedimentary rocks, they will always be layered. So in sedimentary rocks you will definitely find some of the layers. So in sedimentary rocks you will always find layers. Okay, why? Because different components or different materials have come together to form a singular rock. Okay, you will always find layers. Okay, they will never be crystalline, but they will always have fossils, so they can be fossiliferous. So please remember this. So you can have layers, you can't have crystalline structure, but you can have fossils. So if any one of you has watched the movie Jurassic Park, so in that movie you must have seen the mosquito from which they're extracting the DNA of dinosaurs. So primarily the sedimentary rocks. And now if I ask you the most common example of sedimentary rocks, so you can remember the common examples of sedimentary rock like limestone. You can remember a rock called as mudstone. Okay, mudstone you will normally find along the riverbeds, and you can also remember a rock called as sandstone. So limestone, mudstone, and sandstone, these are the common examples of the sedimentary rocks. So please remember, guys, how do sedimentary rocks differ from igneous rocks? So sedimentary rocks will always have layers, sedimentary rocks will never have crystalline faces, and sedimentary rocks can have fossils. Whereas igneous rocks, they will not have any layers, they will always have a crystalline face. Why will not they have any layers? Because they are formed from cooling and consolidification of a magma chamber. So entire magma is cooling and consolidating, entire lava layer is cooling and consolidating. So a big single rock is forming from cooling and consolidification. Hence the sedimentary rocks will have fossils, whereas the igneous rocks won't have fossils. Okay, so common examples of sedimentary: limestone, mudstone, and sandstone. I know that each and every one of you must have seen sedimentary rocks, and igneous rocks I gave you the best example. Kitchen top counters, you have granite. Okay, the third type of rock that you have on earth, it is called as metamorphic rock. Okay, metamorphic rock. Okay, so I won't go into the details of metamorphic rock. You just need to remember that these rocks are formed due to intense these rocks are formed due to intense temperature and pressure. Intense temperature and pressure. Intense pressure and temperature. Okay. Because of intense pressure and temperature. Okay. Because of intense pressure and temperatures, the igneous rocks and the sedimentary rocks they undergo what? They undergo drastic transformation. Okay. So pressure and temperature are very vital for the formation of metamorphic rocks. Igneous rocks and sedimentary rocks under intense pressure and temperature will undergo drastic transformation to form the sedimentary rocks. Again, these rocks will never be layered. So they are never layered, they are always unstratified. As they are never layered, as they are always unstratified, so they will be devoid of fossils. So it is not at all possible to find fossils in the metamorphic rocks. Yes, good evening, Sufyan. Okay, I hope that you are getting these sessions properly. Those of you who are watching me, you are free to comment. Okay, so igneous rocks and sedimentary rocks under intense pressure and temperature will undergo drastic transformation to form metamorphic rocks. And as they are forming under intense pressure and temperature, they won't have any layers. As they don't have any layers, they won't have any fossils, but they can have crystalline structures. Why? Because intense pressure and temperature can result into formation of one singular rock too. Okay, so example wise, if you want to remember the examples of the metamorphic rocks, so you can remember that granite under intense pressure and temperature will result into a formation of a rock called as gneiss. Will result into formation of metamorphic rock called as gneiss. Okay, limestone under intense pressure and temperature, it will result into formation of a rock which is commonly used as floors of your houses. It will result into formation of marble. Okay, so the famous Italian marble, the famous Appalachian marble is basically metamorphic rock. Okay, and sandstone will convert to form quartzite. And sandstone will convert to form what? Quartzite. So these are some of the important examples of metamorphic rocks. Okay, so please remember these examples of metamorphic rocks. This much are okay for us to understand the world maps now. Okay, so again, if I'm painting the three rocks for you, igneous rocks, they will always have crystalline structure. The metamorphic rocks can have crystalline structure, not always, but they do have crystalline structure, whereas sedimentary rocks, they will never have crystalline structure. Sedimentary rocks are the only rocks which are layered, which can have fossils. The rest of the two rocks, they can never have fossils. Okay, so the rest of the two rocks, they are unfossiliferous. Okay, the common examples of igneous rocks, intrusive ones, because of cooling and consolidification of magma, you have granite and you have diorite. If you are having extrusive igneous rock being forming because of cooling and consolidification of lava, then you have the example of basalt, and then you have the example of andesite. Andesite is the common rock of the continental exterior, whereas basalt is the common rock of the oceans. Granite and diorite, they are the common rocks of the continental interiors. Please remember this. So granite and diorite, they are the common rock of the continental interiors, whereas andesite is the common rock of the continental exterior and basalt is the common rock of the ocean floor. Okay, so I hope guys that this classification of rocks on the basis of their genesis is clear to you. Now please understand a very important concept which I told you, which I'll be discussing today. Okay, so beneath the continents, if you go beneath the continents, So each continent, okay, beneath the continent, okay. So before discussing the continents, let us also discuss one thing, that the crust of the earth, or the first layer of the earth, the crust of the earth is divided into two parts. You either have continental crust, or you have oceanic crust. Okay, you have continental crust and you have oceanic crust. And now you know that which rocks are going to dominate this. Continental crust will have which kind of rocks? If you are considering the exterior, andesite. If you are considering the interior, you can have diorite and granite. Whereas the oceanic crust will be predominantly basaltic. Okay, so you know the rocks of the crust. So in a way we have elevated our understanding, in a way we have elevated the way we are seeing now the earth's crust. Okay, so if I'm considering the continental crust per se, okay, if I'm considering the continental crust, okay, so just imagine that this is our continental crust like this. Okay, this is our continental crust. Okay, this is our crust, and below this you have the mantle. Okay, and below mantle you have the core. So beneath you will have core, here you will have core. Okay, so this crust, or this continental crust, mind you, I am talking about continental crust. Every continental crust will have what? Will have a bedrock, or it will have a platform. It will have a platform in the sense of what? That above which the entire continental crust is evident, above which the entire continental mass is resting. So you can consider this as to be the basement or the core rock of the continent, above which the entire continental landmass is sitting. So you can consider this example as the platform of your railway station. So on that platform all the passengers are stationed. So that is how you can have in the continental crust too. So every continental crust will have a bedrock, or a platform rock, or a basement rock, above which the entire continental mass will be bolstered, on which the entire continental mass will be rested. And this bedrock or this platform rock, this is called as craton. This is called as what? Craton. Okay, so if I'm making you understand the definition of craton, so craton is nothing but, okay, the basement, the basement or the platform, or the bedrock, or the bedrock of the continents, bedrock of the continents, And mind you guys, this craton, the basement, the core rock of the continents, okay, how it will form? It will be formed by fusion of, numerous big granitic, or dioritic blocks, or dioritic blocks numerous brick, granitic, or dioritic blocks. Okay, so if you are having big granitic or dioritic rocks, these granitic or dioritic blocks will basically fuse together to form the basement or the core rock of the continents. So what do you mean by craton? Craton is nothing but the basement or the core rock or the platform of the continents, on which the entire continental mass rests. And they are formed how? They are formed by the fusion of numerous big granitic or dioritic blocks. Okay, each of this block, it is called as batholith. Please remember, okay, each of this block, the technical term for that is batholith. Okay, batholith. Okay, this is the technical term. So if you ask me, sir, what is one line definition of craton? So craton is nothing but numerous fused, numerous fused batholiths. Numerous fused batholiths. So that is one line definition of craton. Okay, what is craton? Numerous fused batholiths. What are batholiths? Batholiths are nothing but individual blocks. Okay, individual blocks of what? Individual blocks of granite and diorite. Big blocks of granite and diorite. When they come together to form one block, it is called as batholith. And when numerous batholiths come together to form one big or basement core rock, it is called as craton. Okay, now just get this. This is very important, and I told you that today we will be covering the mineral hotspot regions of the world. So now I'm moving into the discussion of that. Okay, Abhay, you are asking how does olivine form? Olivine, it's basically a part of silicate mineral. So as you move down from the surface of the earth to below, the silica proportion decreases, the iron concentration increases. So it is basically the variation of silica, oxygen and iron which results into formation of olivine. Okay, and olivine is formed under sustained stresses, under intense pressure and temperature, and because of this sustained stresses it tends to lose rigidity. Okay, so it's basically a rock which has iron, which has magnesium and which has silica. Okay, not rock, basically it's a mineral. Okay, minerals will form rock structures will form the landmass. Okay, so now let's move ahead to the most important discussion of today's session. So now just imagine that this is a mountain range like this. Okay, this is a mountain range like this. Okay, below this you have the land surface. So this is our land like this. Okay, and here you have ocean. So this is our ocean. Okay, so okay, let me draw it using green and blue so that you get it very properly. So just imagine that this is our mountain range like this. Okay, this is our land surface. Okay, this is our land surface. This is our sea over here. Okay, so you have sea over here. Okay, okay, and so here you have the land surface like this. Okay, and this land surface is sitting on the basement or the core rock called as craton. So this is our craton. Okay, now what will happen with age, guys? Okay, this sea waves, they will start eroding this land surface. You will also have air, you will also have water. Okay, you can also have glaciers. Okay, you have mountains, so you can have glaciers. Okay, all this will do what? All this will act as agents of denudation. They will cause what? They will cause denudation, they will cause erosion. So as they start eroding, this surface, as this surface erodes, what happens? This craton will get exposed over here. So if I am eroding this surface, okay, if I'm eroding this surface over here, okay, so this surface is now getting eroded because of coastal wave action, because of tidal action, and because of the because of what? Because of the action of agents of denudation. And now this craton is getting exposed. Now this craton has got exposed because of differential erosion. So this craton has now got exposed. So this is now the exposed craton. Okay, this is called as exposed craton, and this exposed craton is basically exposing. Why? Because of differential erosion. You have different agents of erosion like air, water, glaciers, which are basically doing what? They are basically causing the erosion of the land surface, differential erosion, and because of this the craton is getting exposed. So those regions of the world, mind you, this is very important, please understand this very properly. Okay, those regions of the world where you have exposed cratons, or where you have the exposed basement or the core rock of the continents, such regions of the world, they are called as shield regions. They are called as what? Shield regions. So those areas of the world, those areas of the world, those areas of the world where where the underlying where the underlying craton where the underlying craton is exposed where the underlying craton is exposed, okay, due to is exposed due to differential erosion, due to differential erosion. Okay, this erosion can be either due to wind, can be due to either water, can be either due to gravity, or can be either due to glaciers. So different agents of denudation, okay, due to differential erosion. So such areas of the world, they are called as SHIELD. They are called as shield regions of the world. Shield regions of the world. So they are called as shield regions of the world. And mind you, as the underlying rock of the continents is exposed, as the underlying rock structure of the continents is exposed, so these shield regions now become the mineral hotspots of the world. These shield regions now become the mineral hotspot of the world. They become the mineral hotspots of the world. So globally, you will find the intense rich mineral deposit regions of the world to be the shield regions of the world, where the underlying core rock or the basement rock is formed. Okay, so now let us use the world map. Let us try to paint some of the important shield regions of the world. Okay, so I'm now again opening up the atlas, and mind you guys, this will be very important for your understanding of the world. Okay, sorry, my bad, the video was lagging. So wherever you will have okay, so wherever you will have the shield regions of the world, okay, wherever